Good day, grade 10. Ma'am Joji here, your teacher for today. In this video, I will share to you on how you can locate and describe the images formed in a curved mirror. And for you to get along with today's activity, you will need your ruler, pencil, protractor, and paper. You can also pause the video from time to time so you can follow the steps on ray diagramming. From your previous lesson, you have learned that the reflecting surface of a spherical mirror is a part of a hollow sphere. If the reflecting surface curves outward, it is a convex mirror. And if the reflecting surface curves inward, it is a concave mirror. And you also know that the center of the sphere is called the center of curvature, vertex for the center of the mirror, and in between center of curvature and vertex is the principal focus. And the imaginary line connecting center of curvature, principal focus, and vertex is called principal axis. Let us define what is a ray diagram. A ray diagram is a tool that is used to determine the location, size, orientation, and type of image formed by a mirror. And in ray diagrams, there are rules to be considered. First rule, ray of light parallel to the principal axis is reflected through principal focus. For rule number 2, ray of light passing through the principal focus is reflected parallel to the principal axis. And for rule number 3, ray passing through the center of curvature is reflected back along its own path. And for that rules, you just need two of the given ray rules, such as a combination of rule 1 and rule 2 or combination of rule 1 and rule 3. Following the rules, you can find the image location. For the orientation, it could be either upright or inverted. For the size, it could be larger, smaller, or the same size as the object. And for the type of the image, it could be a real image or virtual image. It should also be noted that the process of constructing a ray diagram is the same regardless of where the object is located. Let us now apply these rules on the different cases. For case number 1, object is located beyond C. First, draw the concave mirror. Follow the principal axis and mark the positions for the center of curvature, vertex, and principal focus. Arrow will be used as the object. Let's use rule number 1 and rule number 2 on this case. First rule, from the top of the arrow, draw the incident ray parallel to the principal axis. Obeying the rules, after reflection, it will pass through principal focus. For the second incident ray, it will pass through principal focus, and after reflection, it will reflect back parallel to the principal axis. Notice the intersection of the two reflected rays? Yes, that means that is where the image is formed. With this, we can describe now the image based on the location. The image is formed between C and F. For the orientation, the image is inverted. That is to say, if the object is right side up, then the image is upside down. For the size of the image, it is smaller than the object. And finally, the image is a real image. It is real because it is formed by the real intersection of the light rays, and real image can be projected on a screen. Let us try the same case, but this time using rule 1 and rule 3 to prove that any combination of rays will give the same result. As you can see, it gives us the same result. When object is located beyond C, the image is found between C and F. It is inverted, smaller, and it is real. For case number 2, object is at infinity. Since the object is at infinite distance from the mirror, a rays of light originating from the object travels parallel to the principal axis. These rays after reflection converge and form an image at principal focus. And the image is also inverted, it is highly diminished or a point size, and it is real.
For case number 3, object is located at center of curvature. Following the same rules, observe and try to find out where the image will form. Yes, as for the image, it is located at center of curvature, it is inverted, same size as the object, and it is real. Here's another case for you to try. Object is between center of curvature and principal focus. You can pause the video and find the image by using ray diagram. Let's use Rule 1 and Rule 2. As you can see, the image is formed beyond center of curvature. It is inverted, larger, and real. For this case, what do you think will happen if the object is located at F? That is what type of image will be formed. Again, let's use 2 out of 3 rules. As you can see, the reflected rays are parallel. Reflected rays will never meet. As a result, when object is at principal focus, there will be no image.
Let's try another case for the concave mirror. The object now is between F and B. Let's use Rule 1 and Rule 3. As you can see, light rays diverge after reflecting off the mirror. Where is the image now? You can only find the image by tracing all reflected rays backwards until they intersect. You have to use broken lines to show the virtual lines. Yes, it is behind the mirror. The image is upright and magnified or larger. And it is virtual because the image is formed behind the mirror.
This time, let us have the convex mirror, which is also called a diverging mirror. For image formation, draw the convex mirror, follow the principal axis, and at the back of the convex mirror, mark the positions for center of curvature and principal focus. And for the center of the mirror, the vertex. Similar to the concave mirror, there are also rules in convex mirror. Rule number 1, ray of light parallel to the principal axis is reflected as if passing through principal focus. For rule number 2, ray of light directed towards the principal focus is reflected parallel to the principal axis. And for rule number 3, ray of light directed towards the center of curvature is reflected back along its own path. Notice that the real rays are in solid lines and those behind the mirrors are shown with the broken lines. Let us now try to locate the image if the object is in front of a convex mirror. From the top of the object, draw the incident ray that is parallel to the principal axis. And after reflection, it appears to be coming from the principal focus. And for the second ray, let's use rule number 3, which is a ray that is traveling towards the center of curvature will just reflect back along with the same path. As you can see, reflected rays meet behind the convex mirror. Thus, the image is formed behind the mirror. About its orientation. Yes, it is upright, the same position as the object. For the size of the image, it is smaller, and the type of the image is virtual. To sum up the lesson, the images in concave mirror depends on the position of the object. It can produce both real and virtual images. It can be upright or it can be inverted. They can be behind the mirror or in front of the mirror. And as for the size, it can be bigger, smaller, or the same size as the object. And for the convex mirror, the image will always be behind the mirror, it will always be virtual, upright, and as for the size, it will always be smaller. And that ends our lesson for today, and I'm sure that you are more than ready to answer your science modules. Thank you.